Welcome to Across the Globe. Today we will learn about NumPy basics. NumPy is a Python library focused on numerical computing. It facilitates the handling of multidimensional arrays and matrices, coupled with a suite of mathematical functions tailored to manipulate these arrays efficiently. For instance, imagine a scenario where a data scientist needs to perform large-scale matrix operations for machine learning algorithms. By utilizing NumPy's array capabilities and mathematical functions, the data scientist can efficiently carry out these computations with optimized performance. When working in Python with the NumPy library, you can utilize the np.array function to generate an array. This function allows you to convert a Python list into a NumPy array. For instance, after importing NumPy as np.array 1, 2, 3, 4, 5 creates a NumPy array containing the elements 1, 2, 3, 4, and 5. Subsequently, using print_r will display the array 1, 2, 3, 4, 5. This method streamlines the transformation of Python lists into NumPy arrays for efficient data manipulation and analysis in various applications. NumPy arrays in Python facilitate element-wise operations, allowing for mathematical operations to be applied directly to each element of the array. Using the NumPy library, arrays can be created and operated upon efficiently. For example, creating two NumPy arrays R1 and R2 with elements 1, 2, 3, and 4, 5, 6 respectively, and then adding them together with the expression R1 plus R2 yields a new array 5, 7, 9. Where each element is the result of the addition of the corresponding elements from the two input arrays. This feature simplifies computations when working with arrays, making it easier to perform calculations on large data sets efficiently. NumPy is a Python library that offers functions for array manipulation. Some essential functions include np.sum for calculating the sum of array elements, np.mean for finding the mean, np.max for determining the maximum value, and np.min for identifying the minimum value in an array. For instance, when working with an array like 1, 2, 3, 4, 5, using these functions is straightforward. np.sumr would output the total sum, 1 plus 2 plus 3, 4 plus 5 equals 15. np.mean rr would yield the average, 15, 5. np.max r would return the maximum value, 5. np.min rr would provide the minimum value, 1. These NumPy functions simplify array handling and are invaluable for statistical calculations and data processing tasks in various domains. NumPy is like a toolbox filled with different tools that make it easier to work with large sets of numbers. Each tool in the toolbox serves a specific purpose, just like each function in NumPy serves a specific mathematical operation. For example, the np.sum function is like a calculator that adds up all the numbers in a list. You can think of a NumPy program as a carpenter using their toolbox to quickly and efficiently build a piece of furniture, using different tools for different tasks. Hey, code conquerors, ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The code snippet begins by importing the NumPy library as np. It then proceeds to create a 1D array named R with values 1, 2, 3, 4, 5. Using NumPy functions, mathematical operations are performed on the array. np.sumr calculates the sum of all elements in the array. np.meanr computes the mean of all elements in the array. np.maxr determines the maximum value in the array. np.minr finds the minimum value in the array. The output provides the original array and the results of the mathematical operations. Original array, 1, 2, 3, 4, 5. Sum of array 15/3.0, maximum value in array 5, minimum value in array 1. In a real-world scenario, such operations on arrays are common in data analysis, scientific computation, and machine learning. For example, calculating the sum and mean of values in an array may be crucial in statistical analysis, while finding the maximum and minimum values can help identify peaks and lows in datasets for further analysis. One industrial application of NumPy basics is in the field of data analysis and visualization. For example, In a manufacturing plant that collects sensor data from various machines, NumPy can be used to efficiently process and analyze the data to monitor the performance of equipment, detect anomalies, and predict maintenance requirements. Another real-world application of NumPy basics is in image processing. For instance, in medical imaging, NumPy can be used to perform operations such as filtering, enhancement, and segmentation on MRI or CT scan images. These operations enable healthcare professionals to extract meaningful information from the images for diagnosis and treatment planning. Across the globe, keep learning, stay curious, and I'll catch you in the next video.